Hey guys, welcome back. Well, we got a few days to work on the car, so let's get to it. So let's plan out our electrical. This is kind of one of the biggest things left on the car. So I'll show you a few things. So we're going to try a new approach, which is going to be not really using relays. We're going to use this one. That's a solid state. That's for the trans brake. But we're basically going to do switches to run stuff. We're kind of keeping it simple. So I got these switches. They're supposed to be fairly high quality. These are rated at 50 amps. And if you look at them, you'll see it's a metal case. It's got solid copper with brass screws. These are supposed to be fairly decent. I sure hope they are, because we're about to put a bunch of them in the car. Anyway, 50 amps. That'll run basically anything in the car. We got these terminal strips. These are marine grade, so all stainless steel, heavy duty. And you can do 80 amps per block, and we're going to run 2 of these. Okay, now let's jump up here real quick. So this is like a rough idea of how we're going to do the switches. So basically everything has its own switch. Gauges, a warning panel, go over that in a second. Injectors, ignition, VVT, wideband. So the cooling fan, we're going to have like an auto on or auto off. We got a water pump down here. Okay, computer, trans brake, couple of spares. We got this is our cooling fan for the engine, but it's a manual override. So that way we can run it in auto, or we can run it in manual, or if you turn them both off, it's off. Running lights, headlights, and a push button for the starter. So, that's for the starter solenoid. Okay. So that's our things. That's all the things. This piece is a little out of date. We'd made this a while back. We're not going to worry about that. So, okay, let me show you what this is. So this is a front view. So over here, these 2 rectangles, these are going to be volts and amps coming out of the battery. Thought that would be cool to have. So, hate to break it, but we're not going to run the 17-volt system right now. Let me show you a little bit on that. So we've done some testing. We've been trying all kinds of stuff. I filmed some other videos and never uploaded them because they're kind of boring and there's not a lot of success. So I don't mind posting videos when I fail. But these were kind of boring, so didn't blow anything up really. It just didn't work. So we did fix all of our supplies by changing transistors. I bought 3 of these chokes, and we tried running those to see if we could clean it up. Let me look. I don't see it on the bench, but we built these little capacitor arrays and hooked those up trying to filter it. And we did have some success. Like we got it a pretty good amount better, but it really wasn't good enough. So like this choke, we had it working pretty good, but it was heating up. When I run this at 15 amps, this sucker is getting hot. Now, it would probably work, but I don't like designing stuff where it's on the edge. I want this to be, if this is going in the car, it's got to raise performance, of course, but it's got to be reliable. And it's just not there yet. So hopefully one day I'll figure this stuff out to where I think it's good enough to go in the car, but we're going to skip it for now. So the car is going to run on battery voltage. Whether that's 12 or 16 volts is probably going to be 12, but we'll see. Okay, so coming back to that. So this top row, or there's 2 rows, right? Zoom this in a bit. So these are switches. That's the big switches I just showed you. That's these 50 amperes. Gonna have a big row of those. I believe there's 16 switches going across. And then the top, these are lights. So they'll be green lamps. And every time you flip a switch on, you should see the light turn on. So what that tells you is that you have power to that circuit. So say you blow a fuse. Well, when you flip the switch, you won't see the light because the fuse is bad. Each lamp runs off the circuit that it is. So that tells you that you know your fuses are good when you turn that on. So that's kind of cool. Also, just from a race car perspective, like if you turn on a water pump, like you're not going to hear that turn on if the engine's running. Or a cooling fan, you may not hear that either. So having a light is a little bit of a confirmation that yes, it's definitely on. Okay, so that's kind of cool. Let me flip this around to the back side. So now we're looking at the back, and I'm going to turn the sketch on so you can kind of see the rest of this. So here's the plan for those of you that made it this far. I hate having messy electrical, so I've decided that I think this is going to be better. It'll certainly be easier to work on. Is we're going to basically have, instead of just a switch panel, we're going to put some of the power electronics here. So this big brick and that big brick are these. So this is our fuse panel. So we can run a big fat wire to this coming from the battery. Here's your fuses, and then you get 8 circuits coming out. So that's what these two are. I'll just kind of lay these out. Basically this row, panel, solid state relay, and that's these 3 sections here. So these will be bolted up. And since these power the switches, let me show you a switch. If we put a switch in circuit, say this is the switch, it would be installed like that. I'm just going to lay it sideways. So basically each one of these would jumper and just go right here. So it makes the wiring fairly straightforward. These will essentially be going like switch, 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 and so forth. So that's a fairly clean route for the wires to get from the fuse panel to the switches. Same thing over here. Now they'll come out of the switch up here on this terminal. All of these are going to collect and run across like this, make a big loop down, and they're going to go into these blocks. Let me show you what those are. Okay, so that's going to be a terminal block. These are the ones I'm going to buy are rated for 30 amps, which will be enough for basically everything. They're marine grade, all stainless steel, so should be good to go. And that kind of makes it easier to work on too. So for example, this panel, we said power goes into the fuse blocks, right? So that'd be here, and that would be over here. That's your 2 power going in. All of that goes to the switches. The switches turn and go into this. So basically the top of the terminal blocks, all those will be terminated, and then you'll have a bottom row like this. So if I wanted to remove this entire panel from the vehicle, I would only have to remove this big wire, 8 across here, or 10 or whatever it is, maybe it's 10, and then those. So it kind of makes it to where this panel could be removed from the vehicle without having to like unwire the entire car really. A lot of the circuitry takes place on this panel, and then it just connects to the vehicle. Another big feature that, from a reliability standpoint, that I really like, you don't see any push terminals. You don't see any. I hate those things. I mean, short of like a fuse, like, okay, those push in, but like all this stuff are screw terminals. I can put a ring terminal on this. I can tighten this down. I'm a big fan of these compared to just like push-on style. I don't like those. I like this. So these are all big, beefy. We'll have screw terminals. I definitely like that. You can tug on these and shake them. Like they handle vibration and just bad situations. I've had like the flat ones, like if a harness is getting pulled on, it can just come unplugged. I've had issues where they lose their spring tension and then they start heating up and melting. I've had that happen multiple times. Maybe because they're being overloaded, corrosion, both, don't know. Never had that problem with ring terminals. So everything on this is going to be a ring terminal. So I really like that. Now, here's the funny thing. We were going to make this panel. We're not really going to make it anymore, or not make it ourselves. So what we're going to do is we designed it, and I'm going to send this off and have it cut. Probably just laser cut. What you see now, this is 1/8 inch thick aluminum. We may change that. I'd like to go thinner. It is kind of heavy doing it this way. We come over here, 42 ounces. So whatever that is, like almost 3 pounds, I think. So kind of heavy. We could make it thinner and brace it. I made it this thick because if you do it this way, it makes it easy to, just easy to build. You don't have to worry about like flexure. You could just bolt this thing up. So anyway, this isn't quite finished, but I wanted to show you guys how we're doing this. It would look pretty. I actually did a mock-up of this top section only without all this bottom stuff here, and it looked a little bit better in the car. There's a lot of places you could put this. I guess for those of you that are still here, in the right side of the car when you're sitting in the driver's seat, this is basically in the passenger area. So you basically just twist a little bit and all the switches are right there. But the cool thing is, if this is standing up vertically, is that if you go to the passenger side of the vehicle and you need to work on the wiring, this thing is laid out vertically up and down, and it presents all of this stuff to you. So if you needed to like check a circuit, you have open access to this. And if you needed to like say something just totally gets fried on this and you wanted to take it out of the car, you've got either 16 or 20 screw terminals at the bottom. You got your 2 main leads going into the fuse block. That's it. You're done. The whole assembly can come out of the car. And that way it allows you to work on the wiring outside the vehicle. Not that I anticipate this, but if you wanted to have a spare, you could build a second one of these. Same thing, and you could pop this in the car in probably 20 minutes. So I like that aspect. A big thing that I've learned from in the past is designing wiring that's not serviceable. I could do a whole video on screw-ups I've done in the past related to that. I'll save it for later. If anybody wants to hear about that, let me know. I can tell you how to not wire a car. But yeah, so what I like about this, it's going to be straightforward. It'll be pretty clean, easy to service. I left a lot of room. I typically design everything super tight, but on this, I purposely left a lot of space. Like if you zoom in, I left gaps like 1.5 inches between the solid state relay and this. So like if you come here, the biggest dimension here, I left 1.5 inches, plenty of room to get a wire out and turn it. I don't have to like turn the wire and then pinch it real tight. I've designed stuff that way before. It can work. It's a pain. So we made all this stuff kind of spaced out, give ourselves plenty of room. It makes the panel bigger. It's heavier. That sucks. But serviceability is nice. And when you're in here working, like if this wire moves 1/4 inch, it doesn't bump into that. Stuff like that. Giving yourself a little room, that goes a long way for serviceability. So anyway, hope you guys enjoyed this. We're going to refine this a little bit more, and we'll get this sucker ordered. It'll be getting laser cut, so it'll probably be a couple weeks before it's actually in our hands. But the cool thing is we do the design now, and then we get all the parts ordered, we get this part laser cut, and when everything gets here, it should go together pretty well and actually turn out pretty nice. Anyway, hope you guys enjoyed this, and until next time, y'all take it easy.